Hello and welcome to this tutorial. This is Casey and today we are looking at linear inequalities, and these are expressions to which two values are compared by inequality symbols. It's therefore similar to linear equations except that instead of using an equal sign, it has an equality sign. So there are four inequality symbols: less than, greater than, less than or equal to, greater than or equal to. They're quite self-explanatory and we will explore how they're used in linear inequalities. The first thing that I need to demonstrate is to show the difference between the use of equal sign and inequality sign using a graph. Suppose we have x is equals to 3. This line cuts vertically on x is equals to 3. Nothing more, nothing less. However, if we go ahead and use an equality that says x is greater or equal to 3, the line passes vertically at 3. It extends a region which is beyond 3, that is up to positive infinity, as you can see. So all the region that is shaded is represented by the inequality x is greater or equal to 3. Similarly, we have the same thing. However, this one we have x is greater than 3. The line passes through 3, but this time round we have a dotted line. The dotted line represents our starting point, which does not include 3 all the way to positive infinity. Let's look at how these inequalities are represented in interval notation and on a number line. Suppose I have x is greater or equal to 4. It means the value of x can be 4 or greater than 4. So we have a complete circle from 4 all the way to positive infinity. As you can see, in interval notation, the 4 has a square bracket, means it's included in the inequality all the way up to positive infinity. Next we have x is less than negative 3. In the number line, it has an open circle. That means 3 is not included and it goes all the way up to negative infinity. Therefore, you'd have negative infinity up to negative 3. That's the interval notation. Something you have to take note is that the infinity values, whether positive or negative, they are usually represented by a round bracket. Suppose we have x is greater than 1, which is a true statement, and then we add both sides by 2. We get 5 is greater than 3. So the reason why we're showing this example is that if we add a value on the left side of the inequality and the same value is added on the right hand side of the inequality, the linear inequality symbol remains unchanged because 3 is greater than 1. Likewise, 5 is greater than 3. So if we just have to represent this, we'll put like adding z both sides to x and y. The inequality symbol remain as is. Same applies to subtraction, both sides of the inequality. However, we do have multiplication and division, and it does the same thing, except that the value we multiply should be greater than 0 and should not be a negative. So this only applies to positive values greater than 0. So what happens if we go ahead and multiply or divide by a negative value? Suppose we divide 6 is greater than 2 both sides by negative 2. We get negative 3 is greater than 1. This statement is false. Therefore, what we have to do is we have to flip the sign, meaning negative 3 is less than negative 1. Same applies to multiplication by negative number. We get negative 6 is greater than negative 2. Looking at the number line, this is not true. Therefore, we flip the sign to show that negative 6 is actually less than negative 2. In summary, when you divide or multiply both sides of the inequality with a negative number, we need to flip the direction of the inequality. And we will see many of these examples as we do sample questions in my next tutorial. See you next, and thank you for your time.